Welcome to class time, your daily classroom for CSEC and CAPE subjects. It's now time for CAPE Maths. Yay! I'm O'Neil Morrison, and I'll be your pilot today, and you are my co-pilots. We are going to identify today compound propositions, establish the true value of statements using true tables, identify connectives, negation, conjunction, and disjunction. Connection, disjunction. Okay, so, well, today we're looking at logic and reasoning. You know, it's a challenging topic for most students. So I'll try my best to make it simple for you guys out there. Right, Tyrone? Yes. Well, logic is a branch of mathematics that tests one's ability to manipulate words and letters. Logic is used to distinguish between valid and invalid mathematical arguments. And for valid and invalid mathematical arguments. And myself, when I talk about valid and invalid, I had this thing in my mind back then when I was in school. So I know you must be asking, what does this mean when we talk about valid and invalid mathematical arguments? Well, we'll not spend any time on it, but I'll just give you I'll brief you about it. So what's a valid argument? A valid argument is something that we do daily, right? So for instance, it suggests that if the premises, and we know what's a premise, it's a base. The basis of something that you think about when you're making an argument or a discussion. So the base is that if all the base are true, then your conclusions are also true. In other words, if your premise is true, all your premises are true, then the conclusion is true. And likewise, I always say to my students, if it's not your right hand, it's your left hand. And likewise, an invalid argument is if, of course, if all your statements are true, it doesn't necessarily mean that your conclusion, your premises is true, doesn't necessarily mean that your conclusion will be true. Still confused, I know. Right? Let's look at it like this. For a valid statement, all humans will eventually die. That's my first premises. Then I think again, my second premises. I am human. My conclusion then, therefore, I will die. That's a valid statement. My premises are true, and my conclusion are true. And my premise is that all humans will eventually die, and in my premise I said, or my basis behind that is that I am human. So if I'm human, from first premises, it means that I will eventually die. Right? As I said, we'll give you invalid. It could be the opposite, but we'll look at that further on in the lesson. But just to inform you, I'll give you a brief intro of what valid and invalid mathematical arguments are. Likewise, we say logic is a system based on proposition. I will look at that shortly. Proposition is a declaration statement that is either true or false, but not both. Oftentimes, students, once they hear true or false, they stop at that point. So it's a statement. Declaration is just simple, a statement, an announcement that is either true or false, but is not both. Right? It's important that we understand that. All right. Let's use this proposition. Let's use the proposition. Kingston is the capital of Jamaica. Is that a proposition? Yes, it's a proposition. Because it doesn't matter whether Kingston is the capital of Jamaica or not. We can decide we can tell it's either true or it is false. Right? So it's a proposition. We could also look at the statement. It is raining. Is that a proposition? What do you think, Zidane? All right, let's help you then. Well, it's a proposition, because guess what? If it's raining, it's true. If it's not raining, it is false. Likewise, let's use numbers. 4 plus 5 is 12. Is that a proposition? Javon, you want to give a try? Or you want us to work together? Okay, fine. Javon said, let's work together. It is a proposition. It's not true that 4 plus 5 is 12, but it's either true or false. Right? So that makes it a proposition. I could have said that, let's use this one. 6 plus 3 is 9. Yes, it is a proposition. 6 plus 3 is 9, so it is true. So remember, a proposition is either true, is a declarative statement that's either true or false, but not both. So we looked at proposition. Now we'll be looking at negation. Right? As you see on the screen, we have there some examples for you. You can take them down. You can make notes of them. We just spoke about it. Kingston is the capital of Jamaica. We established that it is a proposition. Whether it's true, it can be either true or false. Rain is falling. It is a proposition because if the rain is falling, then it is true. If it's not falling, then it is false. 4 plus 5 is equal to 12 is a proposition. Even though 4 plus 5 is not 9, right, which is 4 plus 5 is 12, which makes it false, right, it still is a proposition. 17 plus 5 is 32. Of course, that's a proposition because it is true. Next, we look at negation. And a negation is simple. The opposite is the opposite of a simple statement. And of course, a simple statement is just a statement that cannot be decomposed into separate statement. What do I mean by that? I could say, the rain is falling. Right? The rain is falling is a simple statement. Right? It cannot be breaking on in a further statement. So what's the negation of that? The negation of that would have been, the rain is not falling. So it's just the opposite or the reverse of the actual statement. So that's what negation speaks about. So we are going to take a quick break and we get right back to you because some of the students are a little bit tired and need a little break for lunch, for break.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with a cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much.
Welcome back, guys. Jacina's gotten rejuvenated again. See Malik here going and everything. Good. So we're on proposition. Let's look at these. Are these proposition? And give a reason for each of your answers. So, where are you? Is that a proposition? Think about it. Okay, fine. No, it's not a proposition. Remember, a proposition has to be either true or false. Where are you is not a proposition. Right? Let's try another one. Look at this. You can see it's an equation, but is it a proposition? Is it a proposition? Think about it. Jason, what do you think? Of course, Jason, it's not a proposition because there's a variable x that is unknown. If, however, we were to give the variable x a value, then it would be a proposition. But as is, it's not a proposition. Let's look at this one. Is this a proposition as well? No, it's not. Again, we have variables, and we cannot decide if the left-hand side is equal to the right-hand side. So it's not a proposition. Is it true or false? We cannot determine unless we add values to these variables. Let's look at this one. What is an even number? Is that a proposition? No. What is an even number does not give you a statement in terms of its truth or false. So it is not a proposition. Is the square root of 2 a rational number? This would be tricky, I know, guys. But of course it's a proposition. Because remember, it's either true or false. While the square root of 2 is not a rational number, we know that it's a rational number, it's an irrational number. But however, it is false, so hence it is a proposition. So remember this word, negation, we spoke about negation. So negation is just the opposite of an actual statement or a simple statement. So I could say from our previous statement, the rain is falling, as we said. The rain is not falling is a negation. Right? And that would be a negation. We could say 6 is an even number. Then the negation of 6 is an even number would be 6 is not an even number. Right? So that's what we're talking about when we're talking about negation. And we represent it by symbols, which will have a little curly thing. Can use different, depending on the variable that you choose to use, or you could have a slash across the top of it. Right? So there are various ways of representing negation, which will further divulge in as we go further in the lesson. Right? So we just gave you an example of negation. So what we'll do now is look at, as we talk about negation, we talk about proposition, and we talk about true, and we talk about false. Well, at times for students it's very difficult. So what was suggested is that the most convenient way to represent these truth value is by using a truth table. So a truth table can use to help you represent the true value of a statement, right? So we look at some truth tables, and we can also look at the true value for a proposition. All right, so for the proposition we just said, this is a truth table. We'll suggest that the rain is falling. So on the screen, we could see that if the rain is falling, that would represent, let P represent the rain is falling. Then the proposition would be, the negation of that would be not P. And we can represent this truth value in terms of, right? So let's let you see it better. So the rain is falling. The rain is falling. I know I don't write properly. I know. So we said let P, this is our premises, be the case that the rain is falling, right? So the truth table, and I normally say to my students, I'm always asked why, how do you know when you have truth or false and false? So if you remember, that's why it's important that we go to the basics when we're doing sets. In sets, when you want to find the number of subsets in a set, we normally use this formula, 2 to the n, and n is the number of elements, our members, and then you raise it to that power. We know that's raised to the power, and it could tell you. So if you look at it, it's not different. This is P, we are talking about one variable, and it just represents 1, so it will be basically 2 to the 1. And of course, from your indices, rules, and laws, we know that 2 to the 1 is the same thing as 2 to the first, anything you want to call it, it's fine. It's the same thing as 2, so we know that our truth table will be like this. This is P, the rain is falling, and we're talking about, remember, negation, right? And this is your table. And if this is P, the negation will be, remember, it can be written like this, or like a curly thing like that, or you could put it at the top as we suggest. So it's up to you, it's perfectly fine. You see it in books like that. So the true value of this is this 2, so it can be true or it can be false. Right? Therefore, if the rain is falling, the negation will be that the rain is not falling, right? So this should have been our false, right? The rain is falling, the negation, not falling, right? The rain, in this case, it's falling, it's not falling. That means it is true, it is falling. The opposite of, or the reverse, whichever you find comfortable to work with. And remember again, guys, you can also use, you can use 1 for true, 0 for false. So if this is 1 for true, this should be, the negation would be 0. And remember, 1 for true, 0 for false. So if this is false, then this is true. And as of course, that's how it's applicable for those persons who would have done like electrical technology or computer science. It helps you with your programmings and stuff like that. You talk about logic gates and stuff like that. So you'd have been more familiar with the 1 and 0s, right? Likewise, the same thing as true or false. Hope that was good enough for you. And look, and this is it. There we go. So I'll allow you now to see if you can, get your negation for the following statements. First one is, today is Sunday. The negation of today is Sunday. Today, it is the case that today is not Sunday. B, the music is loud. It will be the case that the music is not loud. Lorraine teaches physics. The negation is the case that Lorraine is not teaching physics. Right? And also, you could do the truth tables for these to represent the true value of those statements. Wow, we're going to move on to a compound statement. And if you look at it, a compound statement is formed from 2 or more simple statements. Right? And you remember, I suggest to you that a simple statement cannot be decomposed into separate statements, and we explained that already. So a compound statement is in the form of 2 or more simple statements. And the simple statements are called parts or components of the statements. So that's important. They are called parts or components of the statements. Let's look at these examples. That will help you get a better understanding or a little more clarity in terms of a compound statement. So it says, are the following compound statement? If so, identify the components of the statement. A, the book has 2 pages and the book is yellow. Right? Is that a compound statement? Yes, it's a compound statement. Yes, it's a compound statement. So the book has 200 pages and the book is yellow. Trishan ate cake. Is that a compound statement? No, it's not a compound statement. That is a simple statement. Remember, a compound statement is made up of two or more simple statements. We come back to the formula number here, rational number. Square root of 2. Is the square root of 2 a rational? The square root of 2 is rational and 5 is odd. Is that a compound statement? Yes, it is a compound statement. Right? So, any two statement can be joined with the word and to form a compound statement. That's how we know it's a compound statement. It is joined by the connective and. Right? And why you see we normally use propositions for P and Q, these variables for P and Q? A compound statement is called the conjunction. The proposition of P and Q is called the conjunction of P and Q and is denoted by P and this lovely symbol or connective P and Q. This, the connective and. Right? And there are some guidelines as to know how to determine a compound statement. So it is suggested for you, if you were to do a truth table for a compound statement, it is important that you understand that it is only true when P and Q or the variable of your choice is true. So it can be A and B is true, then your compound statement is true. Otherwise, it is what? False. So a compound statement is true, the true value of that statement is true if both P and Q are true. Otherwise, it is false. We'll get time to look at some of the true values for those, so you can truth tables so you can get a better understanding of them. And there it is, the truth value of the compound statement. And let's draw the truth table for it so you can get a better understanding. And there it is. So based on a compound statement, it says that for both of them to be true, for P and Q to be true, P and Q, for the truth value, P and Q has to be true. Sorry about that. So looking at the table, we can see we have P is true and Q is true. Then, of course, the truth value must also be true. If we have P is true and Q is false, of course, we should know that the truth value will be what? False, because it's only true when both P and Q are true. So, of course, this will be false. And, of course, we could look at that based on your reasoning ability and the understanding of compound statement, that this will also be false and this will also be false, because it's only true when both of them are true. And this will be your true value of a compound statement right there at all the time. Unlike the compound statement or proposition, as I said, if it's not your right hand, it's your left hand. This disjunction on the other hand, the proposition of P and Q is the conjunction of P and Q. It is true, or in other words, it is true if both P and Q are true, or if P or Q is true, just like sets, right? When you use the word or. So it is true when both P and Q is true, or P is true, or Q is true. Otherwise, it is false. So let's use a truth table to help you get a better understanding again. And likewise again, and as I said, you can use 2 to the n, that power that you use in sets, and you can know exactly. You notice we are using two variables, P and Q, unlike with negation, we're using one, where we add just P. So we end up with 4 variables, true, true, false, false, True, false, right? There's two variables, so it's 2 to the second, which should have been 4. So, based on the premises of a disjunction statement and disjunction, we know that it is true when both are true, or when P is true, or when R Q is true, it is true. Otherwise, it is false. So look at this. P is true, Q is true. Hence, your true value will be true. Looking at the other one, true, P is true, Q is false. You still get a what? True. And look at again, P is false, Q is true. You will still get a true. And of course, it means that, as we said before, it is only false when both of them are false. And that would be your truth table for disjunction. There you have it. P or Q, and it is represented, unlike the conjunction is represented with the word, which the connective, I look a thing like a V if you want to call it, I always call it a V. This is the connective that represents the or statement. Right? So it says P or Q is false when both P and Q are false. Otherwise, it is true in a nutshell. So, while you look at those, there's also the case. Yes, this person here, Mr. De Morgan's law, which we had lots of problems with sets. And it comes back again, as I said, see, sets comes back again. So your basis, it's important that you understand the concept that you learn in mathematics. So it is saying that, based on De Morgan's laws with propositions, it is saying that if you have not P and Q, is the same as not P or Q, not Q. Right? Likewise, if you have not P or Q, it's the same as saying not P and not Q. In that case, you can see it's a negation of P and Q with the symbol turned upside down, the reverse. Look at this. Let P and Q be the statements. P, Nikki is a singer. Nikki lives in Trinidad. Write the following using symbols. Right? And we all know what a symbol is. Used to represent words. So, based on what we have done, it says, Nikki is neither a singer, nor does she live in Trinidad. Right? How can we write that? Let's look. Key things we need to identify. It says Nikki is neither. So when it means neither means, if you're neither a singer, it means I'm not a singer. Right? So if I'm not a singer, you hear the word not, it comes back to the word what? Negation. Right? A singer, so she's not a singer, nor does she live in Trinidad. So I'm not a singer, nor means I don't live in Trinidad. So what's our statement for that? And of course, oops, sorry about that. Let me write it here. Didn't have it there. So she's not a singer. So we said P, Nikki's a singer. So it is P, not a singer. Or you can write, as I said, like that, not a singer, nor does she lives in Trinidad. Right? Nor means she don't live in there, so, and she don't live in singer. And she don't live in Trinidad. She don't live in Trinidad, so she don't live there. So write this. Do not live in Trinidad, so it be not. Q. Let's hope you can see it. I write really terrible. I don't know, it's a thing for maths teachers. I'm trying my best. So that would be the statement based on De Morgan's theorem. And based on De Morgan's theorem, we can also express this as equivalent to not P, and of course we turn this up, or Q. So that's what De Morgan law is stating there. Likewise, either Nikki is a singer or she lives in Trinidad. Look at it. Either, the word either comes back to the word. Yes, is either I live in, is it I'm a singer? And the key word is or. So we know the word or. So Nikki is a singer, and it says P represents that. So Nikki is a singer, P. Or, the connective or, and we know we use the V looking up like that. She lives in Trinidad, and it's right there on the board, Q. So that would represent that. statement for the Morgan's theorem. Let's see if we can get in any further. As I said, we'll get time. We'll spend some more time on them. We're just trying to give you an overview of what is expected. Look at these. These are other propositions that you can try. It's a determine whether each of the following statements is a proposition. Right? We looked at proposition. Before you do your math, always ask yourself, what's a proposition? Remember, a proposition is a declarative statement that is either true or false. So you see, I gave you something easy. I will not stress you today out there in TV land. So today is Saturday. We must determine whether the statement is a proposition. Today is Saturday. Of course it's a proposition. Today is not Saturday, today is Friday, but it's true or false. Right? So it is false, so it is a proposition. How far do we live from school? Wow, we spoke about statements like that. That's not a proposition. We can't tell if it's true or false. This just states how far do you live from school. All Cape students must take Caribbean studies. Is that a proposition? What do you think? All Cape students must take Caribbean studies. It's a proposition. It can be true or it can be false, right? And in this case, it is false. All Cape students every Cape student will take Caribbean studies, right? So it is a proposition, right? And we have other ones there. You can see drive to the supermarket, so you can try that for yourself. Curry chicken is delicious. You can try that for yourself and give me your feedback, and I'll look at them for you. And as well, we have here for you symbolic to help you develop those symbolic forms. And remember, symbols are used to represent words, and our symbols, just like our connectives, or your and, or your or statements, or your negation, right? This is me, and Cape examination must begin. So I'll do a few of them, and you will try some for yourself. So the first one, this is me, and Cape examinations must begin. This should be nice and easy for us, because the key word here is and. And why if you notice, I left out some premises for you to develop your own. This is logic and reason. It's for you to think critically for yourself. That is where the country is heading with education. So you can create your own variables. Don't think that, because when you do maths, we normally think about the variables x and y, right? I was so fun. Everything I did was x and y, but you can create your own variables as long as you're in the permutations there. So in this case, I allow you to do things for yourself, for you to feel this is your taking as my students, right? Zidane, so let's look at this. This is me, and Cape examination must begin. What do? I could say sorry about the board, I don't have my duster today. I could say let A, B, I can't even write it down. Let A, the letter A, B, this is me, and let B be Cape examinations. Those are my premises right there, my statements, simple statements. Therefore, I would say A, and of course my connective is that keyword and is represented like that, B. And that's it. So you will try the rest for yourself and send your feedback. Thanks for making it today in today's lesson. Hope you enjoy your day. Thank you.